Hello, this is Ray, and in this video we'll be talking about percentiles. Percentiles are a way to divide our data set into like 100 pieces. And the score, let's say you're taking a test and you scored in the 90th percentile. So it doesn't mean that you got a 90% on the test. It means that 90% of the test scores are less than your score, and 10% of the test scores are greater than your score. So you, in a class of 100 people, let's say, if you scored a 60% on your test, but 90% of the people scored below you, then you're still in the 90th percentile. So the percentile is a way to be able to compare your score with everybody else's score. And percentiles are usually used with large amounts of data. And so we're just going to practice percentiles with small amounts of data, but in general we use large amounts of data, and that's when it becomes a lot more meaningful. But we're just practicing, so let's take a look at it. There are generally two types of percentile problems. One of them is when you have to find the percentile find the value that's sitting in the kth percentile. So let's say I want to know what score you got on the test to be in the 90th percentile. So depending on the scores on the test, you'll get the percentile. The other type of problem is looking at the percentile of a specific value. So given a data set, like the test scores, and say somebody got a 28, then you can ask yourselves, what percentile is 28? Like what percent of the students got less than 28 and what percent of the students got larger than 28? So that's finding the percentile. We'll first take a look at this one, to the finding the value if you were given a percentile. So they give you a percentile and then you find that value, and this is how you do it. So there's a lot of formulas that exist, just like for quartiles. There's a lot of formulas that exist. Not a lot, but a handful of different formulas. But here is one formula that they want us to use for this particular textbook for our class. So we're going to designate certain names for things. So you're going to be given the K, which is the kth percentile. They're going to ask you what number is going to be in the 90th percentile or the 60th percentile. So that they'll give you that. Index is going to be the ranking or the position of the particular data set that you're looking for. So you're going to end up looking for I, the index, and then you're going to count from the smallest number in your data set up to whatever I is. And then N is the total number of data that we collected. So that's the usual number, or that's the usual notation that we use for the number that you collected in your sample. It's N. So here are the steps. First, we got to put it in order. Since this is a positioning type of computation, we need to have everybody in the right position in order. Then we calculate the index. So this is going to be the index. The K over 100 is like giving a decimal for your percentile. And then you're going to multiply this by N plus 1. So it's the number of the total number of data, and then you add 1 to it. And then what you're going to get there is an index. So I is going to be a number. If I is a whole number, an integer, then the kth percentile is going to be in the ith position. So if I was equal to 5 in your computation, then you start from the lowest number, count 1, 2, 3, 4, 5, and the fifth number is going to be that value in the kth percentile. If I is not an integer, then you round up 1 and round down. You round I up and down to the nearest integer, and then you're going to take the average, or you're going to get two integers there, and you're going to take the average of the values in those positions. Okay? Usually when we do these calculations, usually it's not an integer, so we'll get to see hopefully how that works. Okay, so here's our example. We have a list of 29 ages of Academy Award winners, and this is the list. Fortunately, it's already in order. That's great. So let's calculate the 20th and 55th percentile. Okay, so for that, let's do the 20th percentile first. So 20th percentile. That's my shorthand for percentile. And according to the formula, we need to find the index. I is equal to, remember it was k. So this is k, by the way. Maybe I'll put it on the side here. K is equal to 20. So this is going to be k divided by 100, and then multiply it by, there's 29 numbers, so I didn't have to count, but there's 29 numbers here, and then you add 1 to it. So let's punch that in the calculator. Actually, this is, this should be 0.2. Just when you're dividing by 100, you're moving the decimal place 2 units to the left. And so that's 0.2 times, this is 30. And so I think we could do that in our heads, but maybe I'll just punch in the calculator anyways. So it's 0.2 times 30. And we get 6. We got a whole number. So we count 6. 1, 2, 3, 4, 5, 6. And this is the 6th spot. And so the number, or in this case, the age in the 20th percentile is not 6 years old, but 27 years old. Okay, 6 is the position, which is different from the actual age that you're looking for. All right, that's the first one. Let's do the second one, 55th percentile. So in this case, your percentile k is going to be 55. And then we'll do the same thing. We have I is equal to 55 over 100 times 29 plus 1. This is 0.55, and then multiply that by 30. So our calculator tells us that 0.55 times 30 is equal to 16.5. So we round up and we round down. So we want to look at the 16th position. And then we want to look at the 17th position, round up. And then, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And 17. So we take those two numbers, 52 in the 16th position, 55 in the 17th position, and then we find the average between them. So that's 52 plus 55 equals, and then we're going to divide by 2. Divide by 2, and we got 53.5. So 53.5. 53.5 age is not here, but there is going to be like a marker here, 53.5, that says that 55% of the ages are less than that, and then whatever 100 minus 55 is 45% of the ages are bigger than that. So age in the 55th percentile is 53.5. Okay? All right. So remember, there's two types of problems that come up here. One of them is finding the value where they give you the percentile. The other way is finding the percentile when they give you a value from the data set. So let's take a look at that now. Finding the percentile of a value in a data set. So we'll do the same formula. Well, it's not the same formula. It's a different formula. We're going to look for the number of data values counting from the bottom, but not including that data. So this is almost like I, but it's not quite I, so they called it something different. And x is not really a good variable for this, but let's go with that. So this is x. Now, if your value repeats, we have to account for that as well. So y is the number of data values equal to the data value that you're looking for. So if your data value is 7 and it happens like 3 times, then that's going to be the value for y. And n is the same, the total number of data in your data set, and you do this calculation. After doing this calculation, you round to the nearest integer, and then that's going to give you the percentile. Sometimes, generally, for percentiles, you want to round off to the largest or the nearest integer, and you don't say like 26.5 percentile, you just say 26 percentile. Okay, let's give this a try. And in this particular problem, we have 30 Aegis of Academy Award winners for Best Actors, and it's already sorted, which is great. And they want us the percentile for 47. So let's look for 47. This is 47 right here. So age is 47, and we want to know what percentile that is. So we need a couple of things. We need x. X equals the number of values that's less than that. So we count from the number up to, but not including 47. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So x is going to be 15. There are 15 numbers that are less than 47. Y, how many times does 47 happen? It only happens 1 time, so y is just going to be 1. And now we put it into this formula. We got x, that's 15. Plus 0.5 times y, which is 1, and then we're dividing it by n. In this case, it's 30. So it's 15.5 times 30, or divided by 30, almost 50%, or almost, or a little bit bigger than 50%. Let's check. 15.5 divided by 30, and we get, oops, I hit times. Let's try that again. 15.5 divided by 30. 51.6. So this is equal to, I'll put approximately equal to 51 or 0.516, and then we round off to the nearest decimal, or the nearest whole percentage. So I have to move this decimal place 2 places over, 51.6, and then we round off to 52 because 6 is bigger than 5, so 52. So 52nd percentile. So age 47 is in the 52nd percentile. Okay. All right, so that's how we're going to do it. Let's do one more, where we're asked to figure out what the percentile is for the age of 31. Okay, so we'll do the same thing. We'll count from the bottom to the number 31. So anything that's less than that, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers less than 31. Y is going to be the number of times we see 31. So we see 31 twice. So y is going to be equal to 2. Because 31 occurs twice, and then we put into that formula. We have x plus 0.5 times 2 and divided by n, which is 30. All right, 0.5 is 1/2. 1/2 times 2 is 1, so this is 8 plus 1 is 9 over 30. And then let's just punch that into the calculator to get our decimal. That's 9 divided by 30. And these numbers should be numbers that are less than 1. It looks like we're in the 30th percentile. So that's a nice number. It's a whole number. We don't have to reduce. Wait a minute. Let's try that again. 9 divided by 30. Okay. Oh, I skipped steps in my head. So the answer is correct, 0.3. And then you want to write this as a decimal or as a percent. You move this over twice. That's 30th percentile. So age 31 is in the 30th percentile. All right, that's it. I hope that helps. Good luck.